We're going to do a slow motion rotation problem. When I say rotation problem, I mean you're going to take a function or a curve and you're going to pretend that you're going to spin it around the x-axis, and that's going to form like a volume or a solid, and that volume or solid has a certain volume, and we're going to figure out what that volume is. So let's pretend, for example, that we are going to find the volume of a bowl, and that bowl has a shape kind of like this. And the way we make that into a bowl is we take this curve and we rotate it along the x-axis, and we spin it, and when we spin it, it traces out this bowl in space. And we can figure out the volume of this almost as easily as we can figure out the area of the cross-section. And we're going to do that here. And if you notice, I chose the exact same curve we used in the slow motion area of integration problem. We know that the equation for this, which they're going to give to us, is y equals negative x squared plus 2. And we could go into it here, but we do know that the termination point here happens to be square root of 2 comma 0. How do we do that? Well, we know it's something times 0, right? And we know that the reason why this is 0 is because this is on the x-axis, so it has to be 0. So when y is 0, then what's x? So we put 0 equals negative x squared plus 2. X squared equals 2. X equals square root of 2, right? So we know that the x coordinate at this point is square root of 2. Why do we need to know that? Because when we take when we do the integral to find the volume of this rotation, the way we do that is we chop up this bowl into a bunch of little discs, thin discs. Each disc kind of looks like this. And as you can see, as you go along the x-axis from left to right, the little discs that you're forming get smaller and smaller. Okay, and then if you add up the volume of each individual disc, then you're going to get the volume of the whole bowl. And if you chop up the discs in really thin pieces, your answer is going to be exactly correct. Okay, if you chop it up in a few thick pieces, it's going to be close, but it's not going to be exactly correct. So how do you chop it up into infinitely thin discs? You do that with an integral. And what is the width of each one of these discs? Well, when you do it with an integral, you say that the width is going to be dx. Dx is like a variable, and it is a variable which we use limits to make it go to 0. And then we find out what the answer is if we take it to 0, take the limit to 0. The reason why we just don't say dx is 0 is because each one of these discs really had a thickness of 0, then the volume would be 0, and even if you added a million of them together, you would still have a volume of 0, which makes no sense. So that's the reason why we keep the expression dx here. So if we were going to write the expression for the volume of each one of these discs, we would write pi r squared h, which is the volume of a cylinder, and the r value would just be the distance from the middle to the edge, like that, which we know is negative x squared plus 2. Okay, so negative x squared plus 2 is the expression we would use for the r, and then we'd have pi, and then the h is the thickness of the disk, which is dx, right? Okay, so that is the expression for the volume of an individual disk. How are we going to add up all the disks? We're going to do the integral of that expression. And we're going to do that integral between two limits along the x-axis. And the first one is obviously going to be 0. And the last one is going to be this point here. Oh, we've already found it as square root of 2. Do we want the y or the x? We want the x, okay, because we're changing the y. We're changing the height of the disk along the x-axis depending on what position of the x-axis we're on. So this position, we're at x equals 0. So to find this point here, we're going to put negative 0 squared plus 2. So the radius is going to be 2. And when we get to like position x equals 1, then it's going to be negative 1 squared plus 2, which is going to be 1, for example. Okay? So as we move along the x-axis, like here it's going to be with our radius 2, here it's going to be radius 1, and here it's going to be radius 0. So we're going to start from 0, and we're going to go to square root of 2. Okay? And then first thing we're going to do is we're going to actually take the integral of that. And we don't know how to take the integral of a product. So one of the things you could do is you could say, oh, the pi is just a constant. I'm going to put it out front, and I'm going to leave it till the very end. The other thing you could do is you could multiply everything out, and I think I'm going to multiply everything out just to make it easier for you. So you can see that negative x squared plus 2 has the format of a binomial which can be FOILed. So we could do, negative x squared plus 2, and in this case the x term is negative x squared, and then we finally have 2 squared, which is 4. Okay? And we still haven't multiplied pi times each one. We could keep pi out, or we could multiply it times each term. I'm going to multiply it times each term just to, simplify the algebra. So this would be plus 2 pi, and this would be 4 pi. Okay, and we haven't taken the integral yet, so we need to leave the integral sign here just as it was. Okay. Now, since we have negative x squared inside the parentheses, and then we square it, that would be equal to x to the 4th with no negative sign. So it would be pi x to the 4th, and we still have not taken the integral yet, okay? And then we have negative x squared times 2 pi, so that would be equal to negative 2 pi x squared, right? Then we have plus 4 pi, which remains 4 pi. And we still haven't taken the integral, so I'm just going to write here the... Okay. Now I'm going to take the integral. Since it's nice and simplified, it's easy to take the integral. Pi x to the 5th divided by 5 minus x cubed divided by 3 minus 2 pi plus 4 pi x. Okay? And then, since we have taken the integral now, we're going to use the book notation, put brackets around it to show that it is no longer something that needs to be taken the integral of. We've already taken the integral of it, and then now we have this expression, which if evaluated with the limits 0 to square root of 2, we're actually going to get a number which tells us what the volume of the bowl is. So now we just substitute in square root of 2 and 0. And one of the things that might make it easier is, do you know that square root of 2 is equal to 2 to the 1/2? If you use that, maybe it'll make it some exponentials that would be easier to simplify. So here we have x to the 1/2 to the 5th, so it would be x to the 5/2 over 5 minus 2/3 pi, and then we have x to the, x to the 3rd would be 2 to the 1/2 to the 3rd, so it would be 2 to the 3/2, and then we have plus 4 pi, and we have square root of 2, which is 2 to the 1/2 here. And then, where this is, I took this expression and I evaluated it at square root of 2. Now I'm going to take the same expression, I'm going to evaluate it at x equals 0, and I'm going to subtract it from there. So I'm going to have x to the 5th over 5 evaluated at x equals 0. It's going to be 0. I have x to the 3rd divided by 3 evaluated at 0. It's also going to be 0. And I'm going to have 4 pi x evaluated at x equals 0. It's also going to be 0. So you can see that this expression here is just 0. It's going to be minus 0. It does nothing. Okay? And then if you wanted to simplify this, I'm not sure if there's that much you can do, but oops, I wrote here x to the 5/2 is going to be 2 to the 5/2, right? Maybe we could factor out a pi 2 to the 1/2, and if we did, then we would have 1/5 times 2 to the 5th. No, 2 to the, yeah. We would have 2 to the 4/2, 2 squared, minus 2/3 times 2 to the 1, plus 4 pi, not pi, because we factored out the pi, just 4. Okay, 1/5 times 2 squared, minus 2/3, 2 to the 1st, plus 4, plus 4. Okay, so maybe now we can actually reduce this to a number. 4/5 here, minus 4/3, plus 4, and wow, that's not going to be anything that looks nice. The common denominator would be 15. It would be 12 minus 12 over 15. I'm pretending that I don't have the calculator, like it's on a part of the test that we don't have the calculator. 60/15. Okay, and this is all times pi square root of 2. So this is equal to pi square root of 2, and then we're going to have 12 minus 20, which is negative 8, plus 60, which is plus 52. Okay? So, not a nice looking answer, but I think that's right. So you can see that this problem is very similar to the area problem. The only difference is that instead of just putting in the function in the middle of the integral, we also put in, we squared the function, and we also put the pi there, because instead of making little rectangles and adding up the rectangles, what we're doing is we are taking that rectangle and we're going to spin it around and make a little disk out of it. So instead of just having like y times dx as the area, now we have pi y squared dx as the volume of each one of the little disks. And we're just adding them up just like we did before, but now instead, inside the integral, instead of just having y, now you have pi y squared, right? All right.